This API call is digging a user's password. This one is perfectly secure. In this video, I will show you the one simple pattern that makes the difference. Your application works. Your REST API returns the data. Everything seems fine. But there is a silent vulnerability hiding in your controller. A mistake so common, I see it in almost every project I review. A mistake that can expose your users' most sensitive data without you even knowing it. Today, we are not just fixing a bug, we are building a firewall. I'm going to show you why you must use DTO to protect your API. Let's look at a very standard piece of code. We have a user entity. Inside, it has an ID, username, a role, and of course, a password, hash for authentication. And here is our user controller. The fastest way to write this endpoint is to fetch the entity from the database and just return it directly. It's simple. It works. It gets the job done. But what does it actually do? Let's make a call to this endpoint. And here's our JSON response. Let's look closely. We just leaked the user's password hash over a public API. Game over. Your system is compromised. One simple shortcut just created a critical security vulnerability. The first reaction might be, I'll just put JSON ignore on the password field. That's a temporary patch, not a solution. What happens when you add a new sensitive field tomorrow, like a user private email? Will you remember to add a JSON ignore again and again, every single time? Returning your internal database entities directly to the outside world is bad design. Your API becomes fragile and unsafe. Your API is a public contract. It must only expose what the client needs to know, and nothing more. We call this the principle of least privilege. Let me show you the professional way to enforce this contract. The surgeon's fix is not to put patches on your entity. It's to build a proper firewall between our internal data model and the outside world. This firewall is a DTO, a data transfer object. Look how simple and clean this is. It's a simple, dedicated class. It has only the fields that we want to show to the public: ID, username, and role. Notice what's missing? No password. This class is safe to be designed. Now, let's look at the correct way to write our controller method. The logic is almost the same. We fetch the user entity from the database, which still contains the password. But before return anything, we perform a transformation. We map our internal entity to our safe public user DTO. We are building a new, clean object that contains only the safe information. This is our firewall in action. Nothing sensitive can ever leak. because it simply doesn't exist in the object we are returning. And now, the result. Let's call our new secure endpoint. Look at this response. Clean, safe, predictable. The password hash is nowhere to be seen. It never left our server's internal logic. This is difference between amateur code and production-ready code. The first one works. The second one is engineered. Your database entities are for your application's internal use. DTOs are for your public contracts. Never mix them. This isn't about writing more code. It's about writing smarter, more secure code by design. If pattern just protected your entire API, consider subscribing. Because in our clinic, we don't just fix bugs, we build robust systems. See you in the next one.